All right, guys, check your answers with mine. So I've highlighted the answers in yellow just to make it a little bit better to see than the examples I gave you in the last video. So check and make sure you got all those in the right spot. If there are any that you have questions about, please reach out to me, send me an email, and we can talk about why they are where they are. The big takeaway, rational numbers can be written as a fraction, which the application to decimals is terminating decimals and repeating decimals. Rational numbers can be positive or negative, but you will not see, well, never mind. I won't even go there. Integers are going to be our quote unquote number line numbers. So these are going to be our positive and negatives on a number line. So no fractions, no decimals. That's up above in rationals. Whole numbers. Really, the only number that's most specifically a whole number is 0. Past that, 1, 2, 3, 4, 5, those all count below as our counting numbers or natural numbers. All right, so at the bottom of the page, we've got a couple of questions from your book. So they're going to be true or false questions, and the easiest way is to think about this in relation to our grid. So I've got these little arrows. I want you to draw these on top of our chart. And so if you are comparing down, that is going to be false. If you're comparing up, it's going to be true because going up, each of these are built in. So let me give you an example. The number 2, so let's look right here. The number true, because it's all the way down in this counting number, 2 is a counting number. It's also a whole number. It's also an integer, and it's also a rational number. But the number 1/2 is not an integer because it's not on our standard number line. It's not a whole number. It's not a counting number. So going down is false. Going up is true. So let's look at some examples. So number 1 says true or false. If a number is rational, so if a number is rational, then it is also a whole number. So that's going down, and we said that was false. And so an example of that, an example would be the number 1/2. 1/2 is a rational number, but it is not a whole number. And so we disprove a statement. We call it in math, a counterexample. So 1/2 would be an example of a number that is rational, but not a whole number. Are all integers whole numbers? Are all integers, let me get my laser. Are all integers whole numbers? Well, again, look at the arrow. We're going down. So that is going to be another false. And an example of that would be the number -5. -5 is an integer, but it is not a whole number. So are all integers also whole numbers? No. False. Think of my negative numbers like -5. It is an integer, but it is not a whole number. All right, number 3. If a number is greater than 0, then it is a rational number. Okay, if a number is greater than 0, then it is a rational number. Now, we don't technically know about these yet, but there are things called irrational numbers. The most famous one is pi. And so pi is greater than 0, 3.14159, blah, blah, blah. 3.14 whatever is bigger than 0, but it is not a rational number. It is an irrational number because that decimal doesn't terminate and it doesn't repeat. And then the last one, are all rational numbers counting numbers? Are all rational numbers counting numbers? false because, again, I'm going down. And an example of that would be -1. -1 is not, -1 is a rational number, but it is not a counting number. Or 1/2, also a rational number, but not a counting number. All right, and then for sake of time, we're going to skip that one. So in your notebook, go ahead and cross that off, and you can make a little note that we are skipping it. All right, let me clear this out. So let's look at page 14. We are going to look at our positive and negative numbers. If you have this cut out, let me show you how to attach it into your actual notebook. And so in your actual notebook, you are going to attach it like so. Here's mine. I've got each of those dashed lines I cut, and then I wrote on the outside addition on top left, subtraction bottom left, division top right, and then multiplication bottom left. Now, I have just glued it. Just this back part has been glued, and then these dashed lines I cut. Do not cut all the way across, just cut on the dashed line, and now this is going to create some flaps that we can open and close. All right, so I'm going to switch back over and fill in what you're going to write under your tabs. So addition and subtraction are going to work very similarly. So I'm going to draw a little arrow between these two just so you make a note that these act the same. They have the same rules. So if two numbers are being added and they are the same sign, you are going to add and keep the sign. Same thing for subtraction. Add and keep the sign. If they are opposite signs, you are going to subtract and keep the sign of the bigger number. Same thing down here. If they are opposite signs, you are going to subtract and keep the sign of the bigger, hopefully yours fits on a little bit nicer, bigger number. And then something to note, negative, so like minus a negative number is going to turn into a plus sign. I'm going to actually write that below just so we can see that the negative turns into one big plus sign. All right, multiplication and division rules are going to be the same. So let's draw an arrow there for those two. Multiplication and division are going to be the same rules, just like addition and subtraction were the same rules. All right, so multiplication, same signs are going to always be positive for both multiplication and division, and then opposite signs, this one's way easier, are going to be negative. All right, so I'm going to do one from each of the boxes, and then I'm going to let you guys tune into the next video for the answers on that one. So let's look at the first one in each box. So that first one says -3 plus -1. Mine is kind of hard to read, but that is a plus sign. -3 plus -1. These signs are the same, and so I'm going to keep the sign negative and add the numbers. 4. You think about, I spent -$3 and then I spent one more. I went more into debt. -4. All right, let's go down and let's look at the subtraction while we're still on that same mindset. Negative 5, it's hard to see, but negative 5 minus negative 4. Well, we're seeing this negative, negative. I'm first going to simplify that to a positive. Now I've got negative 5 plus 4. My signs are opposite, so I'm going to subtract and get a 1 and keep the sign of the bigger number. So I have negative 1. All right, top right with multiplication, with, oh, my tabs are off. This should be, multiplication and division are switched for some reason. I don't know how that happened. Anyways, so the rules are the same for multiplication and division. With multiplication, negative 3 times negative 4. Negative 3 times negative 1. I'm misreading it. Negative 3 times negative 1. I've got the same signs, so they're going to be positive, and I'll have a positive 3. All right, down below in the bottom right, I have division, and so division is going to be negative 30 divided by negative 6. Same signs are going to be positive, and then 30 divided by 6 is going to give me 5. I do not need to write the positive sign. All right, I want you guys to finish these things out and then check in the next video.